All right, welcome everybody to the October session of our Trimble Business Center Power Hour. Today is Wednesday, October 27th, 2021. I'll be your host today. I'm Shane Lyons. I'm the Technical Product Manager for Trimble Business Center. And I am joined by Trimble's Alex Oxen and Anthony Pascuzzi with Precision Laser and Instruments Geospatial Sales and Support. Alex, you want to go ahead and introduce yourself real quick?
Hello, good morning and good afternoon, everyone. I'm Alex Oxen. I'm the Product Marketing Manager for 3D scanning for Trimble, and I'm based in Westminster, Colorado, and I will be answering some questions as we go along today.
All right. Thanks, Alex. Yeah, Alex, as Alex said, myself and Alex will be fielding any questions, monitoring the question box. We have a lot to get through today, so if we're unable to get to your question, we'll reach out to you guys individually after the session's over and get your questions answered. So with that, I'll turn it over to Anthony, let him introduce himself, go into the agenda, and we'll get started.
All right, thanks, Shane. My name is Anthony Pascuzzi. I work for Precision Laser and Instruments. I was actually the support guy here for a little over 7 years, and then I recently had a role change over into the sales role. What we're going to be presenting today is actually going to be on the X7 and doing Alta surveys. And so our agenda for today is we're going to go over point cloud collection, best practices, target positioning and acquisition, registration check, as well as georeference to georeference the point cloud data, import a georeferenced TIFF image that we collected with our drone. And then we'll finally go into extracting 2D, 3D points and lines. And then at the end, we'll go over the TBC resources in the Q&A. So to start with is point cloud collection. Main key points here that I like to go over is point cloud spacing. The X7 has 80 meters of range. Granted, 80 meters is a pretty far distance to be able to collect data. But truthfully, most scanners, the bulk of the data is actually collected within the first 15 to 20 feet away from the scanner. And if I'm doing a Alta scan and I'm trying to collect a lot of information that's very dense and easy to assess what it is, I usually try to keep my spacing between my scans in between 50 to 75 feet. You can push it a little bit more if there's not a whole lot of features and you have a very large building to work around. But usually 50 to 75 feet is where I kept them. But do keep in mind with the X7, you do have that really nice auto registration feature, but you need to make sure you keep your point cloud overlap in mind. So you can't just scan the face of a building and scan another face of the building without having any overlapping data between them. Otherwise, the registration just will not work out for you. So pay close attention to what you're collecting in each scan to give it the best chance for success. Generally speaking, for point clouds, I try to shoot anywhere between 30 to 40% overlap. And like I said, in the perspective software, it has a automatic registration feature. But what I've tended to notice is once you get above the 25 scans or so, the registration sort of starts having some issues. So I don't like to spend a whole lot of time out there in the field trying to fix everything and get everything exact in the field. I more or less worry about that whenever I go into into TBC. First thing I'm gonna do is do a registration check, and I'll show you how to do the different ways of registering your data. But don't waste a lot of time out in the field trying to get everything exact. It's much easier to do it inside of TBC and post. So for your target positioning and acquisition, Perspective has the X7 rather has the ability to use a laser pointer and be able to scan in targets. In this particular image here, I was using the black and white flippable target that Trimble has. Most recently, actually, I was experimenting with using floor tiles for my UAV and actually shooting those in as well. Either one works incredibly well, but naturally, like with anything else, any other sort of target, the lower you have it, the easier it is, or the more accurate you're going to end up being, making sure that it's properly leveled. And you can shoot them in the field using perspective and using the measure precise point, or you can do it in the the office inside of TBC using the virtual DR command. Just make sure you keep track of which targets they were, what points they were on, and also what your rod heights are. And evenly space them around your project. I usually try to explain this as the same way that you would do like a GPS site calibration. You want them around the perimeter of the project. You don't want them all clumped up in one space. So for our registration check, we want to verify our registration in the field a little bit, just verify that it's at least somewhat close and that things are actually going to match. I really don't worry about if I have exact planar surfaces or doubling of walls or things like that. There is a registration refinement. You can either do this in the field in the tablet whenever you go to export your data, or there's an option there to refine registration. It just depends on how much time you have. If you bring the tablet back and that you're going to export it out then don't bother. Just export the TDX file directly from the tablet and run the refinement inside of TBC. If you are out in the field and you're going to be driving back to the office, and whenever you export it out, just check the run refinement. Depending on how the size of the project is, it's going to determine how much time it's going to run the refinement, and then you'll get that report. Generally speaking, I just look at the tablet, verify that I've collected everything that I need to collect, and get my registration close enough. And the easiest way to verify that your point cloud registration went well is actually either using the plane manager and doing slices to the point cloud to make sure you don't have any doubles of anything or ghosting or weird rotations, or using the limit box. Just, it's up to you, whichever one you think works better. We'll touch on both. And then geo-referencing the point cloud, make sure you watch your RMS values. Nice thing is I think you can geo-reference with as few as 2 to 3 points. I usually try to get 5 if I can, and then I have the option to turn off a specific point if my RMS values aren't as high as what I'd like them to be. So lastly, we can import our TIF or TIFF image. You can process the drone data in any software that you want. I know Pix4D is very popular. UAS Master is another way to do it, and be able to bring those TIFF images in. All you have to do is just drag and drop them into TBC. If they are geo-referenced from whatever software that you're processing them in, it'll just overlay right over top of your survey control. If it doesn't, there is a geo-reference image option inside of TBC as well. And actually, I have another data set where I can kind of show you how that works. So if we have time today, we'll kind of touch on that. But the imagery is great because you're hitting the ground with your scanner at such a flat angle that sometimes it's hard to sort of pick out certain structures in the ground, manholes or cleanouts or things like that. Paint striping sometimes kind of hard to pick out because it's such a flat angle. So now you're infilling that information with the UAV data, and you're able to use the line work on that to be able to establish where those lines are, the structures as well. You'll probably have that on top of the casting, but you may not be able to see the manhole casting right in the actual scan itself. Now you overlay the imagery, and now you can see it a little bit clearer. So once you have all that stuff completed, you have the extraction of the 2D and 3D data lines. So in TBC, in the CAD tab, you have polylines, which are your 2D lines. Then you have line strings, which are your 3D lines or 3D polylines, which you can extract all those things in multiple ways. TBC has actually come quite far in auto extraction, which we'll touch on those things. But the two main line features are curb and gutter, and power lines. Both tools work pretty well. Just depends on how exactly you're going about using them and how good your point cloud collection is. You have points. Obviously we can collect points in either virtual DR or just by clicking on the point cloud and taking measurements. If you have a feature code library and you have those feature codes tied to blocks or something within CAD, you can actually bring those points directly into your CAD drawing, and the blocks will drop right in place, but you can collect them accurately inside of TBC. Virtual DR is huge. Main thing, if you want to use virtual DR for work, is make sure that you have your panoramas turned on at all times, whether you're using an SX10, TX scanner, or X or the X7, make sure you have your panos turned on. Otherwise, virtual DR is not an option for you. And inside of TBC as well, we have auto classifications, and to be able to break the either interior, exterior point cloud into 5 main classifications, so you can have pretty seamless and easy point cloud cleanup. There's a little bit of manual that you'll have to do, but it takes away probably about 80% of the overall work. So with that, we're going to head over into TBC, and I'll kind of show you what I'm talking about here. So first off, whenever you're working inside a TBC or working with your X7, you want to export out a TDX file. So TDX file is listed here under my imported jobs. I have a CSV file dropped inside of here that has all the target controls. And then over here as well is a drawing file showing the actual property lines. And none of those are featured on here because, as you can see, according to my grid, we are non-georeferenced yet. So in order to get this thing georeferenced, after we brought our point cloud in and we've gone through our registration in our point clouds tab, in registration, like I said, if we go into where we have our register scans, we have a few different options here for doing that. If you're using an X7 or a TX, you can actually use the plain base. This works with the TZF file formats. So if you bring this stuff in and you have this one large group of all of your scans and the registration isn't quite right and you just kind of want to run it through its automatic registration, you can highlight all the scans here and you can unlink them, which will break them up in individual scans, and you can click the automatically register and allow the automatic registration to happen. After the automatic registration happens, if you have all one group and everything looks good, you're fine. You can head straight over to the refinement tab and run the overall refinement. If you do end up with a couple different groups because it couldn't automatically register them, you can head over to the pairwise. And in pairwise, you'll see that you'll have your reference stations up top. That's your stations that are not going to move. And then you will have your moving stations down below. And this is going to give you your overlay. So you'll see red would be your reference, green would be your moving. And all you have to do inside of here is just click on a couple of common points and allow them to stitch together. And then, like I said, once you're done with this and everything looks good, then you can hop right over to refinement and run your overall refinement. So with perspective, whenever you're doing your registration, so to speak, you're only really registering one scan to the previous one. You're not actually comparing all of them together. So that's what the refinement actually allows you to do, is it's checking one versus every scan, two versus every other scan, making sure that they all stitch together properly. So actually, I just dealt with someone last week who ran the georeferencing. After they ran the georeferencing, they noticed that only half the scans went over, and a lot of that had to do with the fact that they had forgotten to run through the pairwise. So now half the scans were still at the 0,0 origin. The other half of the scans were up georeferenced. From that point forward, you can go into pairwise, but you have to be much more selective about which ones are going to be your reference stations. Your reference stations would have to be the ones that are georeferenced. Otherwise, you're moving your georeference scans back to where they all began. So that's just a quick explanation of the registration process. But if you do everything properly in the field and you have the necessary overlap, the automatic registration works incredibly well. So after you have that complete, we can go into where our georeference scans are. And again, up here at the top, we're going to see all of our scans listed. And down here, it's going to ask for a point ID and scan point. So what I like to do whenever I'm collecting my data is I'll shoot in my points for control, and then I'll shoot in my targets, and I just give them the same number, but with the T in front of it saying this is the target point. So over here for my georeferencing, all I have to do is click on the 1002 and type in T1002 as my target location, hit plus, 1003, hit T1003, and now I'm going to start seeing my RMS values start to populate and seeing how far off I am. And I know I have one inside of here that's a little bit off. So there's all of my points here. And you'll notice right here, we have one bad elevation, and it's going to add that to the average of everything else. So what I can actually do is I can uncheck this one and say, all right, remove that one from the solution, and let's see how everything else falls. And everything else looks pretty good. If I want to, I could probably turn that one off and then see what remains for my RMS values. And that's all good. And once I'm happy with that, I can just go ahead and click the georeference. And once I click the georeference icon, it's going to take a second for it to move to where it's supposed to be. And you can see where the targets I'm using, how they're evenly around the site. That moved the data. Now if I zoom extends and move into my project, it's tied in and we can actually see the boundary overlaid now. If I hit close, everything should have moved over. So if I zoom extends, all of my points that I shot with my X7 all moved over as well. And now we're properly georeferenced. And we can check that. If you're signed into a Trimble account inside of TBC, there's a little icon down here at the bottom that will allow you to turn your background map on. So if I click that, I logged into this earlier. I don't know why it's doing this now. Third time's the charm. That'll allow you to turn on your background map. So right here, this is just a standard street view. You scroll to the top and you right click on your project and you go to your properties. You can actually change this from a map view and drop this thing down to satellite imagery. And now you can see how well everything, see, make sure your project's in the right space, right place, and see how well everything fits. So we can turn our background map off. So there's our point cloud georeference.
Anthony, real quick, we had a question come in. How did you collect the points from T1002 to 1007? Was it RTK?
The actual points in the ground were, yeah, GPS measurements.
Okay, thank you.
Yep, no problem. So now that we're georeferenced, I can drag and drop and bring in my drone data. And all that it is just this TIFF image. And there's the drone imagery overlaid on the point cloud. Now in our filter manager, I now have the ability to turn off the georeferenced image, turn it back on, and you can see how well or how clear the imagery is in relation to the point cloud data on some things like, you know, these structures down here. And you can see I have some points, maybe kind of hard to tell, but you can see these. You can see the points overlaid on the actual image itself. So if I make them a little bit larger, you know, I may have a hard time picking out that there is a structure there, but now with the imagery here, I can tell, and I can use the points to establish what the rim elevation for that particular structure is. So once we have our georeference image inside of here, and we want to start getting into our point cloud cleanup. Now, again, georeference images and the satellite imagery views and all that sort of stuff are only available within your plan view. Dropping into a 3D view, if I zoom extent, I'm not going to have that ability to use that imagery inside of here, but it's available for me inside the plan view. One nice thing inside of TBC, you have these different tabs here. If I drag and drop one of these tabs and bring it down, I can actually create a new vertical tab group, and I'm allowed to have two views up at the exact same time to be able to look at my information. And it's very helpful whenever I'm drawing lines in the plan view to make sure that they're falling on the proper elevations inside of my 3D view. If I want to bring it back, all I have to do is just drag and drop, bring the tab back in, and it's back to one window again. So now we have the point cloud inside of here. Next thing I want to do is do this extract classify point cloud regions. Now I had already done this on this data set in order to save some time, but it's pretty simple. You're going to have one point cloud to start with, which is going to be your default region. All you're going to do is you're going to click on it, and it's going to break it up into these 5 main classifications, and 80% of the work for you is going to be done. So in the filter manager, if I expand out my point cloud regions, you'll see all those things are turned on. What's nice about it, if I change my color here from true color to region color, anything that does not fit within those classifications is going to stay within the default region. And the default region is shown by kind of like this, I don't know, odd green color. So you can see that's where, you know, people are standing in the scan and where the vehicles are and a few other things. So if I just turn off the default region, now the lot's primarily empty, and I just have my building footprint there, my building and my high vegetation. Turn my high vegetation off, and there's my area of interest, and now I can actually start drawing lines and all of that on here. So before I draw my lines though, and this is another little thing I learned, whenever it comes to CAD layers, it's kind of complicated to go inside of here, draw lines, and have to manually type in all these different layers or put them under something that's preset. TBC only comes with 3 layers. So you have 0, drill, plans, and points. You know, your points are going to go underneath your points layer generally. So in order to get my layers inside of here, you can actually use a DWT file. So if you have a DWT file or a blank drawing file, if you drag and drop that in, now all of your CAD layers will come over with it, so you don't have to manually type those things in or relayer lines as whenever you bring them over into CAD. The other thing we'll bring in as well would be our FXL file for our feature codes for our points. So if I wanted to start off, and let's say we wanted to do this building footprint first, one easy way to do it, or one way to do it, would be using the limit box. So if I click on my limit box, it's going to open up 3D view with this box on it, and I can slide and make this thing fit the building. Go to a top-down view, and then start drawing my lines. The other way to do it, which I think is a lot easier, and close out limit boxes, is to go into your plane manager. And what we're going to do is we're going to create a new plane. And what we can do is call this plane the, you know, something like footprint. We'll make it perpendicular to the elevation axis. And right here, it's going to ask you for a position. So you can pick a place in your building where you're going to get the information that you're looking for. So this one's kind of a split level. So we're going to try to find a plane that's going to fit both buildings at both elevations. So all you have to do is just click on the building, and it's going to generate that plane. So you can see I'm cutting right through here into this building. I'm underneath the windows on the other side. So once I've established the plane, I can hit close and then enter into what's called a cutting plane view. And once you're inside of the cutting plane view, now I can zoom in on that particular cutting plane and see my building footprint. From here, we can change the color. If it's feel like that's too dark, we're going to change this over to color code intensity, which is very easy to pick out. And over here on the right, we can actually change the thickness of that plane. So right now it's set to 2/10. I can make it be, you know, 6 inches. And where that's all going to come into place, make sure you have as much data as possible along that edge. So that, you know, if you're going around, things are blocking it, and you have shadows behind it. Sometimes those shadows at that exact elevation may block off that section of wall. So if you make the thickness a little bit, if you make it a little bit thicker, then you may be able to add more data to the overall footprint. So we can see this actually looks pretty good. A couple little shadows inside of here. But inside of this view, all you would have to do is go to your CAD tab, and we're going to go to our line string. Give it a name. So we just say this is the building, and now we can choose what layer that we want that on. So if I scroll down, go to my building layer, say OK. Now all I have to do is just click on the coordinates where I want them, and I'm just going to do this real coarse. And you can see over there in the 3D view above it, the line actually being drawn while I'm doing this. And generally, I would zoom in a lot more than this and actually pick up every single feature of the overall building. And you see that's where it's going to snap. And from here, we can say new and close. And there's my building footprint line. So if I close out of my cutting plane view, it's going to bring me right back into that 3D view, and we can see that line that I drew through the building. Now, a lot of times whenever you're doing these scans, you want to get your finished floor elevation. So you're either going to know you have a GPS shot or a total station shot of the finished floor, or if you're lucky enough, you can scan inside the doorway to get your finished floor elevation. You can actually click on this line, and under the CAD tab, there's an option here for change elevation. Have it set to absolute, and you can either click on a point or just click on the point cloud where the finished floor elevation is, or manually type it in, hit apply, and the entire line will flatten out to that exact same elevation, which gives you your building footprint on finished floor elevations. If you needed to break this thing up into two different pieces, because if you wanted it up here to have this building pad be on the same elevation, then obviously you would draw this in two different sections. But there's your building pad. If I turn off the point cloud, let's go to my plan view and turn off my scans and my image. Now we can see the building footprint overlaid over top of the actual boundary itself. So we'll head back into our 3D view. And obviously there's a little bit more to it than just that. So we're going to go into drawing lines for, let's say, curbs. So on our curbing, we have the option here to do it a couple of different ways. One of the ways that you can do it is there's a feature inside of TBC now called extract line features. So if I go to this extract line feature command, we can just change this to our curb and gutter, and we're going to define a cutting plane. Just like we did here inside of our plane manager, we're going to do it, but on a smaller scale on this. The most important thing whenever it comes to extracting your curb and gutter and establishing this cutting plane is that you make it as parallel as possible. If you have two points that are establishing the cutting plane like here and here, the data looks a little bit off because you're looking at it from a skew. So put one right here and get one as parallel to it as possible, and that will establish a very nice slice for your cutting plane view. So we can see here. So we're going to now choose our nodes. So there's our back of curb, face of curb, our gutter. And we don't have to draw all of these at the same time. We can just say I only want node 1 drawn and node 3 drawn. And we can add or remove nodes depending on what exactly it is we're trying to follow. We also need to look at the arrow, which direction it's pointing to extract. So actually we're going to switch direction and we're going to go down that way. And from there we can say extract. Now it's going to continue on, and it wants you to redefine where these nodes are as you're going along if the profile changes too much. And from here, I'm just going to go ahead and say finish. That's more or less the idea behind the automatic curb and gutter. So go ahead and say finish here. But that's going to give you your 2 lines. And if I go to my post QA QC, I can change what layer those lines go on. So if I just set it to curb, add all, and close, now my lines are in place. The other line string was set to 0, so I'll just go to the properties of that line and change its layer to where it needs to be. Actually, I messed up on the first one. Actually, yeah, so I need to change this one to being my back of curb. And there's my two curb lines drawn in through the automatic extraction. The other way that you can do it, depending if it's 2D or 3D, obviously, is you can do it from your plan view, or and just by manually clicking on the points, just by going to CAD and then going to your line string command, and we can give it a name of curb. And let's say this is going to be our curb gutter. And if I go to my plan view, I'm going to go to where that line ended here. And the reason why I have to go into plan view is because plan view is the only place that's going to allow you to do the snap. So I can snap to that line and then go to back to my either go to my 3D view or continue it on it just inside the plan view. And this is really helpful if you're just doing 2D and you don't really care about the elevation aspect of it. But if you care about the elevation, you want to make sure you go into your 3D view. And in our point cloud side, we're going to go back in this perspective-based mode. And we'll zoom in on that section. And we'll click along and do it that way. And just make sure to change in between a straight section, or if there's a curve coming along, like in this case, to draw your curbing in. And again, this is the reason why I say that 50 to 75 feet to make sure I have plenty of data here in order to be able to draw these things out directly in this view. So a little bit time consuming if you're new to it, but if you do it a lot, it actually flies by in getting these lines drawn in. So there's that one drawn in. So the other way to do this is if you've done a scan there and you can see the data pretty clearly, then you can go to that scan station. So right here I got scan 9 that I did right from this position. So if I go into what's called a station view and I scroll down to that scan 9, I can then see the top of curb here, the back of curb rather, and I can go to my CAD line string command again, changes to my back of curb. And with this virtual DR checked, I can actually click on the screen and give myself my starting point. And just keep working up that edge. So make sure to switch it back. And if you need to, if you have another scan there, so let's go from here from 9. Let's see where we went to 10. And now we can actually continue that on. And make sure we put nodes at our breaks for the ADA. And there's that line drawn in that way. So we can do it manually, just looking at the point cloud, We can do it automatically through the automatic extraction, or we can do it using virtual DR and drawing lines in that way. Virtual DR also comes in handy inside your station view for generating points. So if I needed a building height shot here, for instance, I can go to create point, make sure, again, my virtual DR here is checked, give it a ID, give it a feature code, double click on my northing, go in, put that shot in. It's going to populate the northing, easting, and elevation. Hit add. Now I have that point up there showing my building height. And just to verify its placement, we can go into the 3D view again. And we can see that we're at the extreme height of our point cloud, essentially the building height, top elevation for that building.
Hey, Anthony, we have a question. Someone's asking if you can show how to open the DR window.
The DR window?
I think he's talking about the virtual, to take the virtual shot.
Okay. That's just within your point clouds tab and opening up your station view, which is right here. Choosing which station that you want. And make sure this virtual DR is set. If you're talking about the image, like when the image pops up with a little crosshair, that comes up automatically whenever you actually click on the image. So as long as you have the northing here selected, you can click anywhere that you want, and it's going to bring in the zoomed in image. So if the building's really tall or really long, that's where you start messing around with changing your panorama settings. If you're using the SX10, you may want to switch it from the overview camera to the primary camera, or the X7. Change it from using the faster image acquisition to a little bit slower, and have it take double the images so you get more higher resolution images. Okay, so that's generating your points one by one by using that the virtual DR command. If you want to, there's also the option here for extracting point features. So inside of our 3D view, for instance, if we had power poles here. So here's one in this particular location. Under the point clouds tab, there is extract point features. And if I have it set to pole and just in manual mode, and I click on a pole and I say extract pole features, apparently doesn't like that pole. What it's going to do down here is going to give you the pole diameter and the overall pole height, as well as do a plumb line. So depending on your feature code, so power pole here, I can then select the attribute that I want it to go to. And when I create that, point, I can add that, and it'll actually put the block down there for me for that power pole. Now you can do this independently, just in the manual mode, or you can click automatic, and as long as you've done your proper processing of the data, or the classification of the data, it should go pretty quickly, and it'll automatically place all these things for you. Same thing with trees. So if you have a particular tree, and if I turn my high vegetation on, there's an option inside of there to switch from power poles to trees. So here's one that's sitting here kind of on its own. We can change this over to that and click on the tree, extract the tree attributes. And again, we have that. We just need to make sure we have a proper feature code. So here's one for my spread. And here's one for the height. And again, I can go ahead and add that as a point. Oh, it's because I didn't adjust my feature code library. That's my bad. But whenever you drop that in, it'll actually put a block in there according to the feature code library for that particular tree. And you'll see there's the actual block for that tree location. And what's nice about the points inside of these for trees and poles is it's not just a random point on the face or around the tree. It tries to extract the exact center of the actual tree itself. Same thing with the pole. It's going to give it an exact center on that pole. So that's your 2D and 3D line work, or actually, sorry, just your 3D line work. So for our parking striping here, if I go back to my plan view, and again, this is with the imagery turned on, I can very clearly see my parking lines here. If I go under the CAD tab and I go to polyline, these are 2D lines. I can put this under paint and scroll down to my pavement marking layer. And I can just click on the image. I can just click on the image and create the line work inside of there. So with one line drawn, this one line drawn here, I can take a measurement from that line to this line and come up with a horizontal distance. And I can use in the CAD tab my offset command, choose what layer I want to put it on just by clicking on the layer and clicking on the line, give it an offset distance, say of 9 feet. Make sure I change the offset direction to go the right way. And now I can automatically draw in or drop in all my paint striping locations. In the exact same sort of way we can do it over here on the other side. Now, obviously on a curve like this, you're gonna have to go about and manually do that sort of stuff. But whenever you have these nice straight lines, just use your offset commands. There's a lot of really nice CAD commands inside of here, just like if you're already using Civil 3D or things like that. So, you know, you have your offset, you have your join, you know, trim, extend, all that sort of stuff. So if you've established a boundary of the curve line here, if I turn off my imagery and my point cloud, if I wanted to extend my line here to that, you know, all I have to do is click on these two, and actually I'm going to join these. Join those into one line, and I can use my trim extend and extend these lines over, and using that as my boundary in order to get these things drawn in. So basic same line commands that you would have inside of any other CAD package. You can do them right inside of here. Now for the aspect here, going into the 3D and entering into the whole surfacing thing, once we've drawn in our 3D lines, you can use those things actually as break lines. So if we were going to generate a surface off of our point cloud region, so let's say we turn on our ground region alone, I don't really want to have however many points are inside this ground region, 87 million points. So another important thing when it comes to point cloud information is to segment the data down. So what I'll actually do here under our point clouds tab, we have the option here to create a region. So I'm going to put it in polygon select, and I'm just going to grab out this area here where I drew in my curve lines. And I'm going to create a region, and I'll just call it lot surface. And I'll turn off my ground. And what we can actually do is click on this, and again, still that's 4.4 million points. In our point clouds tab, we have the option here to do what's called sampling a region. So if I sample the region, and I say, you know, just give me a point every 6 inches. In this case, let's say, yeah, let's stick with 6 inches. I can say store. Still plenty of information there. So if I click on it now we only have 10,000 points. I can click on the point cloud region, go under surfaces, just click on create surface, give it a name if you want, hit apply, and that generates the surface. Now these lines here are not break lines yet until I click them each and I go under surface members, and then I add those as surface members. And now that will add those as being break lines to that surface. So once you've gone through and you've drawn all of your lines, absolutely everything that you need to draw, you can use all your curbing features, structures, catch basins, inlet structures, whatever they are, and add those into your overall surface. And when that's complete, you can generate your contours off of there. The one word of caution I have about generating contours inside of TBC is if you're more familiar with generating them inside of AutoCAD, TBC does not allow you to generate two different layers for your contours. So you don't have an index and interval contour layer. You only have just the contour layer. So you may want to generate your contours directly inside of AutoCAD. So whenever I would export this data out to get it over into CAD for final draft, under your Home tab, you have Export. And under Export, I would export all my line work out as a DWG or DXF. And you can choose down here if you want to export out as 2D, but if you're doing this 3D, obviously you don't want to do that. But if it's just a 2D Alta, you can change this thing to 2D. So export out your CAD for all your line work. Export out your points just by using the custom tab, point northing, easting elevation code. And then under the construction tab, there is a land XML exporter, and that will allow you to export out your surface file, and that will come straight into AutoCAD for final draft. The other thing that I think is pretty neat inside of here, once again under your point clouds tab, you have an option here for doing what's called processing panoramas. And in process panoramas, it is going to balance the exposure and blur the edges in between your images. So it makes it look a little bit cleaner and more polished as far as panoramas are concerned. And then you have an option here to either export the station panorama as a JPEG or as a KML KMZ file. So if you are wanting to share existing conditions with someone for them to be able to see the data that you're working off of, you can export those things out as a KML KMZ, and then anybody can open up each one of those stations, look at each one of the station panoramas for a software they probably already have on their desktop. So hope all that was informative. You know, and feel free to ask whatever questions.
All right, we're coming up. Anthony, if you want to go ahead and pass it over to me, I'll go over a couple things. Then second, show my screen. Okay, can you guys see my screen?
Mm-hmm.
Okay. 50%. Okay, well, first off, I want to thank Anthony for taking the time to put all that together. That was a great session. There are some questions up here. We are running down to the hour. I want to go over a couple things, so we will reach out to everybody, get your questions answered. As I said, hopefully for the next day or two, we'll get a list of all the emails from everybody that's registered, and we'll get back with you. So I just want to go over a couple things. We do have a lot of TBC resources out there, a lot of learning material that covers a lot of what Anthony has gone over here. All this content is free. One of the best ways to access all of our stuff is within our TBC homepage. We have a TBC Resources PDF presentation. This is something that we keep up with on a bi-weekly, monthly basis. We're constantly adding material to it. Inside of that document, you have links to our TBC website, our support page, YouTube channels. The YouTube channels has tons of videos and playlists for certain workflows. It has sample data set that you guys can work with and practice on some of the stuff that we're learning. And then We have our e-learning channel as well, which can be accessed within the support ribbon of TBC and within that PDF presentation. The e-learning is something we're constantly adding to. We will be adding, I believe we have about 14 courses up there right now and 4 different learning plans. Some of that stuff does cover what we looked at today. And we're going to be adding some more stuff. With the upcoming release, we'll have a couple more cadastral courses coming in, and then a feature extraction from Point Cloud's course as well. So really do encourage everybody to go to the homepage, select that resources document presentation, download it and take a look. We also have everything sorted out with video content by subject. So it's a big document we're constantly working on and updating. So join us next month for our TBC Power Hour. It will be held on Wednesday, November 17th due to the Thanksgiving holiday. And we're going to kind of take a step back. We're going to go back to the basics. Trimble's Stephen Shepard is going to show some workflows to simplify TBC by customizing ribbons and working with the workflows that fit whatever your project is. So with that, I want to thank everybody for joining. We do have a little bit of time for some questions, so let me jump over here. We have a question here. What was the main function behind the TIFF?
What was the point of importing the
TIFF.
TIFF image?
Yep.
Oh, just to infill the imagery that was collected off the drone. Like I said, the imagery off the scanner. The imagery off the scanner and the points off the scanner sometimes are hard to see on objects that are flat on the ground further away from the scanner. And yeah, you can increase the amount of scans that you do, but I look at every single scan as like 4 to 5 minutes of time. And if it's on something that I know I have the ground data on it, I'll just send a drone up in the air for 10 minutes to collect the information, and then I can overlay the 2 different data sets together. I actually just did a Alta over the weekend, and looking at the previous collection that was done a few years ago, the drone helped because they never called out a courtyard that was actually in the building itself. So we are actually able to gather more information by using that than we would have if we just would have done everything from the ground conventionally.
All right, thanks, Anthony. We have another question here. What were the computer specs for your computer that you were using for the demo? Do you know that offhand?
Yeah, it's Alienware Area 51M, 64 gigs of RAM, RTX 2080 with an i9 9900. And about 3 terabytes of solid state drive. But truthfully speaking, I've had this computer for about a year and a half or so. Absolutely awesome computer, but I've run data with less power, and I've had pretty good results. The main thing that I find with like higher end machines is that they seem to have a problem with heat sinking. And that's kind of the reason why I've stuck with the Alienwares. Yeah, they're heavy beasts, but they get the heat away from them. I had a Dell computer that whenever it would start processing data, you'd hear the fan start to spool, and then it would just not spool anymore. And eventually I think it lasted maybe 3 weeks before it was finally done. But 16 gigs of RAM is the absolute minimum to me anyway. If 32's twice as good. A dedicated graphics card is a must, and run Intel NVIDIA paired together, and that'll get you the best results.
And we do have some documentation out there that kind of shows our recommended specs. So I'll get that over to you as well. There's another question here. Would exporting a station view KML, as briefly shown towards the end of the presentation, why does he get the error? Oh, that's something I'll get with you afterwards. That's something we can get resolved. Here's another one. When you set up the plane for CAD, does that have to be horizontal or can it be at an angle? They need to draw floor pans for uneven cave floors.
So no, those ones can be done at an angle. If you're doing that and you're trying to extract, you can set it to be a vertical plane, and then you can use the slider to slide the plane along that, so you're taking multiple slices essentially. And there's stationing on that thing as well that you can manually type in. So if your station 0 is at the far north of the site, you can slide that thing along like every 5 feet and be able to draw in lines or create points along that if you're trying to take very accurate measurements.
All right, thank you. So we are coming up here. We're going to go ahead and we'll call this a session. We have a lot of questions on here that I'm going to go ahead and get back with everybody on. A lot of the stuff we have documentation on as well. But yeah, just want to thank Anthony again for all the hard work he's put into this, and I hope everybody has a great rest of the week.